Hello everyone, I am Martinus Bagus Wicaksono, and in this occasion I would like to present my homework entitled Smart Car Remote Controller via IoT. These are the components that I use to develop the smart car. There are some motors, 4 motors, and then this is the L298N as a DC motor driver, and I use the ESP32 as the controller, and then for the sensor I use the ultrasonic sensor. Those components will be wired based on this schematic diagram. So actually here I use only 2 motors in this schematic diagram, but in the reality I use 4. So the right side motors, there are 2 motors on the right side, and then it will be they will be connected parallelly to this port, and this also same on the left side motor. And then next will be the interface of the remote controller. So we have 5 buttons: forward, left, backward, right, and stop. And then there is a distance measurement. Here is the distance, and then here is the measurement value. So basically it will measure the obstacle in front of the ultrasonic sensor. Okay, we can continue to the Ento-IO setup. So this is the Ento-IO setup, and here first we have to create the thing. I have created the thing. I use the smart car as the thing name, and then inside the thing we have 2 channels. The first is motor channel, and then the second is ultrasonic channel. In the motor channel I use integer type so that it will create integer from 0, 1, 2, 3 and up. And then for the ultrasonic channel I use the float type, so the value will be displayed here based on the measuring of ultrasonic sensor. Next we have to create the key. This is the key for smart car. And again, in the magnifying glass, we have to set those channels to be active channel. So we have to check all the boxes here. So in the motor channel, we have to check read and also update. And then for the ultrasonic channel, we also need to check read and the update. So this is the Ento setup. We have finished setting up the Ento, so we can continue to the Visual Studio Code generating. And here we have 3 indexes. First is index.html, and the second is index.js, and the third one is index.css. So in the index.html, basically here we will create the user interface. So those all buttons will be set up here inside the index.html. inside the index HTML, we divide it into 5 rows. This is the first row, and then second row, third row, fourth row, and fifth row. In the first row, it is used to create the distance information. So here there is a distance here, and then for the second row, used to show the value of the distance. So basically the measurement value, which is created from the measuring process of the ultrasonic sensor, will be displayed here. At the sample, there is 89 on the user interface. And then for the third row, it is used to create those all button. Basically, those all button will be like a 3 by 3 matrix. So every row will be divided into 3 columns. For the first row of the button, there are 3 columns. The first column will be empty, and then for the second column will be set to create the first button, which is forward button, and then for the third column will be empty. So this is the first row of the button, and then the second row of the button, there are 3 buttons. The first column is set to create the left button here. This is the left button, and then the second column will be set to create the stop button, and for the third column will be set to create right button. And then this is the last row of our button. In the last row, is also divided into 3 columns. The first column is empty, and then the second column will be set to create the backward button, and then the third column will be empty. So there is the code inside the index.html. Next, you can go to index.js. In the index.js, we create those all function of the button. So first, we create the function of the forward button. Here, the forward button will refer to Ento AI. And if we press the forward button, it will set the channel of motor. So the motor channel will be set to 1. So it means that if we press forward button, it will give the value of motor channel to be 1. And for the left button, it will set the motor channel to be 2. So it will give integer value 2. And for stop button, here, stop button, it will set the motor channel to be 3. And for right button, will give integer value 4. And then the next is a backward button. It will give the channel value to be 5. And then next is set the interval. So I use my timer and then set the timer into 200 milliseconds. So every 200 milliseconds, it will get here, it will get the value of ultrasonic channel. So this is for the index JS. So the function of every part in the remote control interface. And then next is index CSS. Index CSS here basically contain the properties of our button and also the measurement value of our sensor. Next, we can go to the Arduino code. Here is the Arduino code. And in the Arduino code, I use the two libraries. First is Ento.io, and then second is HCSR04 for the sensors. Here, same with the previous project, we have to set those all connection, SSID, password, user to Ento.io, and then key, thing, and also the channel. And then next, in the 12th row, we set the sensor. The trigger pin and the echo pin will be connected to pin 18 and 19 respectively. And then after that, we set the speed car into 200. This is like a PWM. So it will set the speed of our motor. And then for the pin in the DC motor driver, for enable A, connected to pin number 14, enable B to 27, and then for the motor A, the pole connected to pin 26 and 25. And then for the motor B, the pole connected to pin 33 and 32. And then the next is the point forward. Basically, this is like a subroutine that it will be called every forward button is pressed. So if forward button press, then it will make the A motor rotating forward in speed car velocity. And then for the B motor will be rotated into forward direction in speed car velocity. And this is for the backward. Basically, the backward is the opposite of forward. And then for the right subroutine, we have to make the right motor rotating to backward, and then left motor rotating to forward. So the car will turn to the right direction. For the left, it will be the opposite of the right subroutine. And then next is the stop. For the stop, basically we turn off those all motor that we have, so the car will not move to any direction. And then after that, this is the serial print to check the status of our microcontroller. So if we run the system, then we have to check which is our microcontroller connected to the SSID that we have or not, so that we can control the car using internet connection. And then after that, we set the Ento MQTT to subscribe channel M. Channel M is motor channel. In the void loop, we set the code. The first is we have to read the sensor. Here, the sensor will check the distance of the obstacle in front of the sensor. And then we set the Ento MQTT publish the channel S. Channel S is ultrasonic channel. So we publish to the ultrasonic channel, and what will be the value? The value is the distance of our measurement value. And then if the distance greater than 400, it will be read as 400 here. And if the distance less than 30 centimeter, then the flag stop will be set to 0, and then the motor should stop. Because right now, if this condition is achieved, it means that there is an obstacle in front of the car in distance less or equal than 30 centimeters. And here, if this condition is happen, then microcontroller should publish to the motor channel 0. It means it will stop the motor that we use to make the car moving. And then if the distance greater than 30 centimeter, the flag stop is set to 0 again. Next is the logic of our control. Here, if the button is pressed, then it will set the value. So here, the microcontroller will check the channel M. Channel M is motor channel. If the value in the motor channel equal to 3, it means that the stop button is pressed. So microcontroller will stop the car. And then if the motor channel equal to 1, so the microcontroller will call the forward subroutine. It means that those all motors will rotate in forward direction, and it will make the car moving forward. And then if the motor channel equal to 2, it means that left button is pressed. So the microcontroller should call the left subroutine, and the car will turn left, and this is for the right and backward. So this is the Arduino source code. After we have this all code, we can upload this code to the microcontroller that we have. Next, we can continue to the Firefish deployment. So we can use CMD here, and then go to our directory. My directory is in the drive A, and then we can write our path. After we have our path ready, then we can type Firefish init. Proceed Y, and we can choose hosting configure file for Firefish hosting, and then hit enter. Use an existing project. Here we use the smart car. Just hit enter anyway. After we finish, then we can go back to our directory. Then here we have public directory. We can copy the index CSS, index HTML, and also index JS to the public directory. After that, go back to the CMD again, and then type Firefish deploy, and then enter. Wait for a second. Okay, the deploy process is completed. So we can use this URL address to have the remote controller interface in our gadget. So basically, if our gadget or our laptop connected to internet, then we can control our smart car using the remote controller interface. Okay, this is the end of the process. Next, we can see the video of our system working. So this is the end of my presentation. Thank you for your kind attention.